Good afternoon. Good afternoon. Now I'm moving on to question 2.3. Remember, I told you that I'm going to separate 1.1 and 2.1 and 2.2. I'm going to do them together, and 2.3 separately, 2.4 as well, and 2.5. So let's go through this now. We want to go through this question. So guys, whenever you have a question about drainage patterns, what comes to your mind? The drainage patterns that we have. You have got your trellis, you have got your dendritic, you have got your deranged, you have got your rectangular, you have got your parallel, you have got your radial, you have got your centripetal. So you have to know the different types of drainage patterns. And by knowing them, I mean in terms of how to describe them, in terms of how to identify them, in terms of how to explain how they are formed. So let's see what we have. We have got these two diagrams. We have got this A and we have got B as well. There's something that I want you to take note of. Can you check here? Check here, guys. Guys, you can't tell me that you don't know what A and B is. You are given the answer here, guys. Trellis and dendritic pattern. This should guide you guys. Please get as much information as possible from the source or the sketch or the diagram or the infographic. Go through everything. What is the source? Where was this diagram or the sketch derived from? Where was it taken from? Okay, then it can actually give you an idea of, or it can give you some clues on how to answer some of the questions. Identify the drainage patterns A and B. You can see in the sequence that they are written, trellis and dendritic. This is your trellis. So this is your what? This is your trellis. This is your what? Dendritic. I got it here, guys. I got it here. Besides the fact that I know what this type of drainage patterns are, I got it here. Okay, let's move on so that we don't waste time. So this is your trellis and your dendritic. Differentiate. You are now asked to bring the difference between the underlying rock structure of the drainage pattern A and B. They have got different underlying rock structure. Why? This is why they are different in terms of their shape, in terms of how they are formed. Okay, this is why they are different, because they have got different underlying rock. Okay, let's see. For A, alternating layers of hard and soft rock or folded rock structure. So there is alternating layers of hard and soft rock on the trellis or a folded rock structure. This is the underlying rock where the trellis is formed. Alternating layers of hard and soft rock and also folded rock structure. When it comes now to our dendritic, the rock that is uniformly resistant to erosion, the rock that is uniformly resistant to erosion. So that's how you answer this one now. It's uniformly resistant to erosion, which means it's your uniform rock, okay? But this one is hard and soft rock or a folded rock structure, okay? Let's move on. Why are the tributaries of the main? Why? Reason. You're giving the reason. The tributaries of the main parallel to each other in the mainstream parallel to each other in the drainage pattern A. So we are now saying now, why are they parallel to each other? The tributaries of the main, these ones, why are they parallel to each other? Remember, we have said that it's made up of hard rock, okay? Hard and soft rock. Obviously, the streams flow in relation to the folds of the rock. Remember, we said folded rock structure. Or the streams flow over soft rock of the syncline. Remember, when you talk about the syncline, anticline, syncline. This is your syncline, this is your anticline. That's basically what we are talking about, okay? So we are saying the stream flow over soft rock of the syncline valley. Interflows are parallel. That's the reason there, okay? Determine the stream order at 1 in the drainage pattern B. What is the stream order? So this is how you do it, okay? So you look at, okay, we are going to say 1, 1, it gives us 2. 1, 1, what does it give? It gives us 2. Then it means 2, 2, stream order 3, okay? Then 1, 1, it gives us 2. 1, 1, it gives us 2. 1 and 2, it gives us what? 2, stream order 2. 1, 1, 1, it gives us 2. 2 and 1, we get 2. 1, 1, we get 2. 1, 2 and 1, we get 2. Of course, 1, 2 and 1, we get 2. Can you see? 2 and 2, what do we get? We get 3. So is the third order. Is the third order. At 1 here. is the third order. You have seen how I have done it. Is the third order. That is the correct. So here is the what? Third order. That is the correct answer. Choose the correct word between brackets to make the statement true. Okay, the higher the stream order, obviously the higher the drainage density. You can see here the stream order 4. So the higher the stream order, the higher the drainage density. The correct answer there is higher. Drainage density, we are referring to the total length of streams per unit area, which means where we have got a higher stream order, we have got more streams. You can see the number of streams that we have. The higher the stream order, the higher the drainage density. So that is the general principle there, which means the lower the stream order, the lower the drainage density. The higher the stream order, the higher the drainage density. Okay, refer to the drainage pattern B and describe the relationship between. So when we are looking at B now, drainage density, that's what is being assessed now. Drainage density, total length of streams per unit area. We are saying now, refer to the drainage pattern B, which is your dendritic, and describe the relationship between. Okay, if we are to look at this drainage pattern, we are saying now, what is the relationship between the drainage density and low rainfall? That's what we are saying. So we are saying now, when we are looking at drainage density, what is it that we are more concerned with? We look at two processes of runoff, surface runoff, and infiltration. These are the two processes that we look at. We are saying now, where there is more surface runoff, there is what? Higher drainage density. Where there is more infiltration, there is low drainage density. So these are the two processes that help you to understand drainage density, which means where we have got more surface runoff, we have got more streams flowing, that's resulting in higher drainage density. Where there is more infiltration, which means there is less streams flowing, water is infiltrating. Like for instance, all right, let me use what we have here so that I don't confuse you. Which means where we have got low rainfall, what will happen where we have got low rainfall? The low rainfall will result in lower drainage density because there will be less streams flowing. That's basically what we are saying. The low rainfall will result in what? Low drainage density. So this will result in low drainage density. This will result in low drainage density. Why are we saying that? Because there will be low streams flowing, less streams flowing. It results in low drainage density. If we have got more rainfall, we are likely to have more streams flowing. We are likely to have more streams. We are likely to have higher stream order as well. That's basically what we are saying. But where we have got a steeper gradient, just steeper gradient, as soon as we receive rainfall, what will happen? The water will start flowing, which means we have got more surface runoff. So here we have got a higher drainage density. So steep slope encourages a higher drainage density. Why? Because as soon as we receive rainfall, we have got more surface runoff. There's more water that is getting into the streams. That's basically what we are saying. So we are saying the less the rainfall, the lower the drainage density. The more the rainfall, the higher the drainage density. Same applies here. The steeper the gradient, the higher the drainage density. The gentle the gradient, the lower the drainage density. So steeper gradient encourages more higher drainage density because there's more surface runoff. Low rainfall, there are less streams flowing. Or when the water is flowing, let's think of drizzle. What will happen? The water percolates, infiltrates. So there is more infiltration. Then we are likely to have a lower drainage density. That's what this is all about. So this takes us to the end of 2.3, which covers drainage patterns and also explored the concept of drainage density.